Hello and welcome to Lesson 2B, Graphing Linear Equations and Functions. Guys, 80% of this lesson, maybe more, is all Algebra 1, so it should be a no-brainer for you guys. The first thing I'm going to talk about is how do you recognize that something is a linear function? Well, here's what a linear function doesn't have. There can't be any exponents, so looking at this, that immediately says that this right here is not a linear function, and nor is this one, because there's a square and a cube. No other functions inside there, where here I see an absolute value, that's a function. It's gone, and x cannot be in the denominator. So this guy's gone too. So of this group of 5 functions, my only linear function is this guy right here. And we usually have linear equations in 2 variables, an x and a y, which can be written in the form ax plus by equals c, where a, b, and c are integers. This is called our standard form. To rewrite that as a function in function notation, we're going to solve for y and replace the y with f of x. So looking at this, x minus 3y equals 12, I'm going to solve for y. I first subtract the x over, so I have negative 3y equals negative x plus 12. Divide both sides by 3 to get y equals 1/3 x minus 4. And at this point, we replace the y with f of x. So to write this as a function, it's f of x equals 1/3 x minus 4. There are 2 very important points on every graph, and they're very easy to spot. They're your x and y intercepts. Well, your x-intercept is where you cross the x-axis. This is my x-intercept here. And we would write that as 3, 0, guys, because it's a point. We always list the x and the y value. My y value, on the other hand, is over here, and it's at the point 0, 2. That's my y-intercept. So, moving right along, if we want to find the y-intercept, I am going to let x equals 0 and substitute in the equation and solve for y, and my y-intercept is always going to be at the point at x is 0 and y is b. We use b because of y equals mx plus b. B is always your y-intercept. To find the x-intercept, we're going to let y equals 0, and we're going to substitute in the equation and solve for x. My x-intercept, therefore, will always be at a, 0. So let's see what this looks like in practice. If I have the equation 3x minus 2y equals 6, I can actually graph this by finding the intercepts. So I'm going to do that. I'm going to let y equals 0. So 3x minus 2 times 0 equals 6. That's 3x minus 0 equals 6, or 3x equals 6. So x is 2. So my x-intercept is at 2, 0. And my y-intercept, and I can actually plot that, my y-intercept, we're going to let x equals 0. 3 times 0 minus 2y equals 6, or 0 minus 2y equals 6, or negative 2y equals 6, so y is negative 3. So my y-intercept is at is at 0, negative 3. So when we plot that, we plot like this. So to finish graphing this, all I have to do is draw a line through those 2 points. Now there's actually a shortcut here, and it's actually called the cover-up method, and I want to show you that real fast. And the way the cover-up method works is if I want to find my x-intercept, I cover up the piece of the equation with the y. So in this case, I would cover up that. I'd have 3x equals 6. I can really quickly get to x equals 2. It saves tons of work. Here on the y-intercept, I would cover up the part with the x. I'd end up with negative 2y equals 6, so I'd get y equals negative 3. It's just a faster way to go about it. All right, guys, I want y'all now to try part B. Give me my x-intercept, my y-intercept, and graph it. Go. All right, guys, take a minute and check your work. Make sure your graph matches my graph. Let's go on to the next. So next we have slope-intercept form, where we are going to, a slope-intercept form of the equation is of a line where my slope is m and my y-intercept is 0, b, is your favorite, y equals mx plus b. This is definitely the form of the equation that we are most used to seeing. So slope reminders. There are several ways to find slope. The first is through the slope formula, y2 minus y1 over x2 minus x1. Remember, guys, the difference of your y's is on top. We can also write that as the difference of y over the difference of x. We can also count it on a graph using rise over run, which is probably my favorite method if we have a graph. And then remember that if we have a completely horizontal line, my slope is 0, and a completely vertical line has an undefined slope. So let's find the slope of each. So looking at this is a graph. I am going to first locate 2 pretty points. And unfortunately here it's not very clear, but it's clear in your book. I've got a good pretty point there and another good pretty point here. And I'm going to count what is my rise and what is my run. Well, we rise 2 and we run 5. So this would be slope of 2/5. All right, guys, I want y'all now to do part B on your own. Here we fall 2, go over 1, we get -2 over 1, which is -2. Now, let's look at somewhere we need slope formula. Here I want to find the slope through 2 specific points where they give me the points. I'm going to use slope formula. Your slope equals y2 minus y1 over x2 minus x1. It really doesn't matter which one you make x1 and y1, which one you make y, as long as you're consistent. So I'm going to do x1, y1, x2, y2. So here at y2 is 17 minus y1 is 5 over x2 is -35 minus your x1 of -17. I end up with 12 over, that ends up adding to be 52, -50, or no, I'm wrong. To be 12 over -18, which will actually reduce. 6 goes into both, so I get -2/3 as my solution there. All right, let's take a look at this guy through the points 6, -2, and 19, -2. Take a minute, guys, and solve that one on your own. And when we plug that in, we get 0 over 13, which equals 0. That means, guys, that this would be a perfectly horizontal line if we graphed it. All right, now take a look at C and tell me what you get on C. And you should get that your slope here is undefined. All right, let's go on to the next page. Now we're going to talk about graphing by rewriting the equation in slope-intercept form, solving for y, identifying the slope in the intercept, and graphing the line. So this is probably the way that you're most familiar with graphing a line. So the key here is to isolate your y values. So I would do -4y equals -3x plus 4. We divide everything through by -4. I get y equals 3/4 x minus 1. Now, this right here is my y-intercept. This here is my slope. We always graph the y-intercept first, -1. Then we use rise over run to plot a second point. That means we'd go up 3 over 4, and we could do it again, up 3 over 4. And we draw a line to connect our points. I want you guys now to do B and C on your own. Go. Right, take a moment and check your answers. Make sure you have the correct equation and the correct graph. All right, let's go on to the next page. Now, I want to take a look at an example of a linear equation word problem. While manufacturing 2 different camera models, Kodak found that their basic model cost $55 to produce, whereas the deluxe model cost $75. The weekly budget for these 2 models is limited to $33,000 in production costs. The linear equation that models the situation is 55x plus 75y equals $33,000, where x represents the number of basic models and y represents the number of deluxe models. So if I want to complete the ordered pair solution 0, blank of this equation, I would plug in 0 for my x. This would be 55 times 0 plus 75y equals 33,000. And basically that goes away. To solve this, I simply divide 33,000 by 75. I'd hop into my calculator. We do 33,000 divided by 75. I'm going to get that as a decimal. We get 445.9. So we would get y equals 445.9. This means that when no, we put x is the 0, where x is my basic models. When no basic models are produced, they can make 445 deluxe. So it'd be 445.9 here. We're saying 445 though, because if I make 446 models, we're going to go over budget. So I'm being careful there. It's not correctly rounded, but it's correct for the context of the problem. Now, if we're looking at the ordered pair, blank comma 0, that means I'm going to let my y value be 0, meaning I'd have 55x plus 75 times 0 equals that 33,000. And this time, this piece goes away. So to solve this, I just divide 33,000 by 55. I go back into my calculator. 33,000, oop, too many zeros, divided by 55, and I get 600. So that means your x value here is 600 here. So when no deluxe models are produced, they can make 600 basic. All right. If 220 deluxe models are produced, again, guys, deluxe is my y value. So if we have 55x plus 75 times 220 equals 33,000, find the greatest number of basic models that can be made this week. This is simply solving this equation. So I'm first going to multiply 75 by 220. I come over here, I'm going to do 75 times 220 to get 16,500. So 55x plus 16,500 equals 33,000. I'm now going to subtract 16,500 from 33,000. Come back over here. 33,000 minus, grab that from up above. It's the same. Oop, nope, wrong thing. Over here. So now I have 55x equals 1,000 or 16,500. Divide both sides by 55 to get the x by itself. Divide by 55, I get 300. That means x equals 300. You can make 300 basic models. All right, let's look at horizontal and vertical lines now. Y'all learned an acronym a long time ago, HOIVUX, which we're going to come back to in a second. But first, let's graph the line through the points 3, 2, and negative 1, 2. So I'm going to graph the point 3, 2, and the point negative 1, 2. When I graph that, and I put a line through those 2 points, we get a perfectly horizontal line. And every point on that line has a y-coordinate of 2. So my equation here must be that the y value always equals 2. That's how we describe that. And my slope here happens to be 0 because the rise is 0 and the run is actually infinite, so we get a slope of 0. Here we have the point negative 3, 4, so I'm going to do negative 3, 4, which is here, and then the point negative 3, 1, negative 3, 1. And when I graph the line that connects those 2 points, we get a perfectly vertical line. And every point on it has the same x-coordinate of negative 3. Therefore, my equation must show that every x value is always equal to negative 3. It doesn't matter what the y value is, but the x value is always negative 3. And my slope here is undefined because it would be something over 0. So coming over here, let's look at some examples now. I want to write the equation through the following lines. The vertical line, 2, 5, well, vertical lines are always x equal equations. So this must be x equal 2. It's whatever the x value is. Whereas my horizontal lines are always y equal equations. Y equals whatever the y value is, which is 5. I want you guys now to do these two here on your own. And we should get y equals negative 1/3 and x equals 2/5. Now, let's take a look at the slopes of these lines down here. X equals 5 remember the slope of any x equals equation, x's are always vertical lines, so this guy here is undefined. Whereas a y equals line is always horizontal, and horizontal lines have a slope of 0. So I want you guys now to do the last two questions here. Okay, go ahead and check your work. You should get a slope of 0 and a slope that's undefined. All right, let's talk about parallel and perpendicular lines. Lines are parallel if their slopes are equal. So if M1 is equal to M2, if they're exactly the same. Lines are perpendicular on the hand if my first slope is equal to the negative reciprocal of the second slope. That means the slope is an inverted fraction of itself and it's negative. So let's look at some examples down here. I want to classify each line as parallel or perpendicular. So looking at this first one here, identify the slope of each. My slope here is -4 and the slope here is 1/4. So that means, because I've got a -4 and a 1/4, well, if I took the -4 and I flipped it, I'd have -1/4, then I change the sign and get +1/4. These guys are perpendicular. So let's look at the next one. I have y equals x plus 2 and y equals x. My slope here is 1 and the slope here is also 1, so these guys are parallel. I want you now to look at the next two on your own. Go ahead. So on the second one, we have a slope of 1/3 and a slope of 3. While those are reciprocals of each other, they are not opposite reciprocals. There's not a sign change. So we would say that's neither parallel nor perpendicular, so we just say it's intersecting. And on the following one, those are both y equals equations, and y equals equations always have a slope of 0. Because they're both slopes of 0, they must be parallel. Go ahead now and take a look at the next one on your own. So here you have a slope of 2 and a slope of -2. They are negatives of each other, but they're not reciprocals, therefore they're just intersecting. Now, on the next two problems, we actually have lines that haven't yet been solved, so we can't actually see their slope yet. So before you can do these, you actually have to solve them first. So when I solve this guy, I would just subtract the 2x over, so I get y equals -2x plus 4. This one over here, I would first subtract the x, so -2y equals -x plus 2. I divide both sides by -2. I get y equals 1/2 x minus 1. And when I do that, those slopes of -2 and +1/2 are opposite reciprocals, so these guys are perpendicular. Go ahead now and do the last two on your own. So on these two equations, we would have y equals -4x plus 8 and y equals 4x minus 4. Those are negative slopes of each other, but they're not reciprocal, so they're just intersecting. Now these two are a little bit different. Y equals 4 has a slope of 0. It's actually, I'm going to graph both of these so we can get a sense of what's happening here. Y equals 4 would be a perfectly horizontal line where the y values are always 4. He'd be here. Whereas x equals 3 is a perfectly vertical line where your slopes are always undefined. Your x values are always 3. If you look, perfectly horizontal and perfectly vertical are always perpendicular. So anytime you have a y equals equation and an x equals equation, they're always going to be perpendicular. All right, guys, that's the end of this lesson. Take a look at the practice assignment. Thank you.